Hello, my name is Alex. In this series of video tutorials, we'll concentrate on how you can write a module that works with a database. This course focuses on what a model is in Magento, which brings us to the last letter, the M in the MVC concept. For this course, to better understand the concepts we use, we'll take a real task as an example, as we did for the previous courses. Let's say we want to provide a customer with the ability to add a comment on a checkout page to add details or special instructions for the merchant. The module we write will save this comment into a new database table, and then show all these comments in the customer's profile. To get this done, we'll create a new table for storing customer checkout comments. Then, we'll create a model, a resource model, and a collection, and learn what they are. Instead of using a controller, in this course we'll master one more concept, the event observer. We'll learn how Magento works with a database, how to use a model and a collection, what the role of a resource model is, how to create a new table using an install script, and how to read and write new values to the table. Let's get started. Our first step is to create a module skeleton. So we need a module name. Let's call it Checkout Comments. Typically, a module consists of an initial configuration file, a namespace folder, a module folder, and at least an etc folder with a config.xml file. Let's start with the initial configuration file. Open the app etc modules folder in your Magento installation and create a file named practice_checkoutcomments.xml there. Open the file and add the code you see on the screen. Based on the material you learned earlier, this code shouldn't require any explanation. Then, move to the local code pool and create a folder named Practice there. This folder is a namespace of our project, so it might already exist from the previous course. The next step is creating module folders. Create the Checkout Comments folder in the Practice folder. Next, create the etc folder, and then create the config.xml file inside. Next, open config.xml and add the code you see on the screen. Now the skeleton for Checkout Comments is ready, so we can move to the next step, creating a table in a database. In Magento, to create tables in a database, we use database setup scripts. As we often do while creating a module, we first define the item, then create it. To define a setup script, you must name it. To name it, you must know the version of the module for which the system will run the setup script. The first time a given module is called, the system applies all of the database setup scripts that have a version less than or equal to the version of that module. Do you remember we mentioned that it is good practice to include the version node back in our first course when we created our first configuration file? Now you see why it's important and how the system makes use of it. See line 5. Open your config.xml file and add the code you see on the screen. What does this code do? It defines our setup script. But technically speaking, this code just instructs the system to look for the setup script in our module. We don't have to define each setup script. It's enough to tip the system off to look for resources in the folder. We see this from the Resources node on line 10. Then, in the next line, line 11, you see Checkout Comments_setup in lowercase. This is the resource name. When does the system use it? If you open the Magento Model App class and move to the Run method, you will see the _init modules method on line 336. Scroll to line 402, where the method body is located. Take a look at line 408. You see here a static Apply All Updates method call, don't you? Here's a place where the system applies all of the SQL install and update scripts. Let's look at the body of the method. It's in the Magento Model Resource Setup class on line 219. On line 224, the system collects all global resources entries for system configuration. Then, it checks if there is a setup entry in a given resource on line 227. If there is, the system sets the current class name value in the class name variable on line 230. This value is taken from the PHP magic constant, class, and equals to Magento Model Resource Setup in this case. So the static function applyAllUpdates is ready to create here an instance of its class, which is the default behavior. Note that on lines 231 through 233, this class name value can be replaced with another class name from a class node of config.xml. And finally, on lines 234 and 235, the system instantiates the class and runs its applyUpdates method. Let's go back to our config.xml file. We don't have a class node, and that means we rely on Magento Model Resource Setup functionality to process our setup script. That ability to override the setup class allows you to add some custom logic for the system to use when it installs your custom module. In our case, native functionality is more than enough. Let's list what this code contains so we can be sure to understand it and remember it. Line 11 defines a resource name, checkout comments _ setup in our case. Next, there is a setup node. This word is hard-coded, as you just saw in the resource _ setup class. And finally, the setup node contains a module node with practice _ checkout comments as a value. The system needs to know the module to which this resource setup corresponds. So that is why we put that module node inside the setup node. At minimum, you must have all these lines to use setup scripts. When the system instantiates the resource setup class in line 234, it passes the resName variable, that is, the resource name, as a parameter. The system can use it to find and replace the default credentials for a connection with a database on line 132 and 141. This provides you with the ability to use custom credentials in your module's resources, such as a different database or another user. The second important node that we have in our config.xml is the module node. The system takes its value on line 139. This allows the system to extract only the configuration of the given module from the entire system configuration object and sets it into the module config variable. This takes place on line 140. If we write step by step all the method names we traced, we'll see the sequence I show you on the screen. The system will use this module config object and the method getAvailableDB files to build the path to the folder with the module's database scripts. Notice the sequence in which the system reaches the method getAvailableDB files marked in red on the slide. When all relevant database scripts are found, the method getAvailableDB files uses the getModifySQL files method to sort and filter files by version number and then returns them to the ModifyResourceDB method, which will, depending on their type, either include them or run their content. Our next step is to create the setup script. Let's move on. In this video, we're going to create a setup script. In Magento, modules have a folder named SQL for the SQL setup scripts. Why SQL? The directory is called SQL for historic reasons, even if setup scripts nowadays contain more than only SQL. Let's create this folder in our module now. Next, we need to create the folder Checkout Comment Setup inside the SQL folder. All letters need to be lowercase. And finally, we create the file install001.php. This file is our setup script, and 001 in its name must match the module's version in the config.xml file. In a previous video, we mentioned the getAvailableDB-files method. In the method, the system builds the path to our folder on line 481. That's why we named our folder exactly the same way. We named the resource in config.xml, namely checkoutcomments_setup. You see that the system uses it to build the path. The module node that we defined in the setup node is also indirectly used here to build that path. The system gets the module name to use as a prefix from the mod name variable. See line 479. Now the file's dir variable points to the app code local practice checkout comments SQL checkout comments_setup folder. Next, the system will scan that folder for all files that match patterns defined on lines 488 and 489. You can see examples of file names that the system can match in the Apply Update steps. MS SQL and Oracle here are simply an example of database-specific install and upgrade scripts. In Magento, we have only the MySQL adapter available at the moment, so only the first two options will work, marked in purple. The system will also match these file patterns, but with the difference that it will run the content of the files instead of including them. Notice that using plain SQL for setup scripts is deprecated and is not used in the core. It exists only for backward compatibility. The functionality of whether to include a file or run its content is in the Modify Resource DB method on line 624 and 630. Our file will be included on line 624. Okay, it's time to add content to our setup script. Now open the install001.php file and add the content you see on the screen. The code will create this table. Here you can see the output of the showCreateTable command for our checkout comments table. In Magento versions prior to 1600, you might see that new tables were created in a manner like this. But this approach will work only on a MySQL database, and that is the reason why setup script files were prefixed with MySQL4 like this. MySQL4 install 100.php. Now we recommend that you use a new approach, available since the 1600 version of CE. If a file is named like this, install 100.php, or another version number, the system will use it for any available database adapter. That makes non-prefixed install script files the cross-database or universal install files. They are compatible for any database engine if a corresponding database adapter is provided. And this is the reason why our code is a little more complex than before. We must avoid database-specific details when writing cross-database scripts. To create a table object, we use the new table method as shown on line 7. Each field we add with the add column method, as shown on lines 8, 14, and 18. To add a primary key to the table, which is on line 12 on the screen, now we add a specific value to the array. On line 9, you can find identity true. This will create a primary key for the comment ID field. To add a foreign key, we use the add foreign key method and prepare a unique name for the method using another method, getFKName. This method guarantees that a key name it produces is unique across all database keys, which matters for most database engines except MySQL. And the last detail I want to mention is comments. Now, you are advised to provide a comment for every field and for every table. We did that on lines 13, 17, and 19 for fields, and on line 29 for our table. Using comments is mandatory when we write cross-database scripts like install001.php. Finally, on line 31, we call the method createTable with that table object as a parameter. When the system successfully processes this method, we will have 3 fields in that table: comment ID as a unique identifier for each comment, order ID, which stores a connection with an order in the system, and comment field, which stores the text of the comment. As you see, the comment field is of type text. So when you need a field of text in MySQL, use the type text constant of the VariantDB DDL table class and specify 64K as the length for the field. On lines 2180 through 2195 in the VariantDB adapter PDO MySQL class, you can study the details of which field length and the parameter you should provide for a text type field to get the expected results. To provide the field types that you need, use constants of the VariantDB DDL table class. Excellent! We have created the first part of creating a database table, namely creating the setup script. Now let's actually create the database table. If you refresh any page, the system will try to install our new module and create the checkout_comments table. Let's do that. Oops, we've got an exception. That was predictable since we told the installer to get the table name via configuration. See line 7. We did not provide this information yet. To do this, we need to define the model and resource model. So let's postpone testing until we've defined them. To prevent scripts from running on each page reload, the system stores resource names and their versions of install and data setup scripts in the core resource table, as you see here. The system won't look into the SQL folder again unless it detects that the version of the module differs from what is in the database. That is when the system will use files like this. They are upgrade files for the catalog module. If you open the config.xml file of the catalog module, you will see that the version is 16005. This means that on the install step for the catalog module, the system runs the install_resource_db method and the method runs install scripts first. Take a look at the method body. Line 421 means that the file install1600.php will be applied first. And then, line 422 means that those 5 upgrade files will be applied too. Here are the upgrade files. This mechanism allows you to easily upgrade your module by changing its version in config.xml and providing proper upgrade files with the applicable range of version numbers and their file names. Files with a MySQL 4 prefix are still in use. They will work only with a MySQL database, and we call them database-specific setup scripts. You may want to use them when your script is targeted to only that specific database. To summarize, the file names shown on this screen can be used for creating universal setup scripts and database-specific setup scripts. When releasing a new version, you can use upgrade scripts. Here, you can see all available options for you to follow. One more word of recommendation: don't place code that adds new data into the database in the install or upgrade scripts. Keep that code separate in data install or data upgrade files. They were designed for this purpose. Take a look at the data folder of the catalog module as an example. This folder contains two files with data to be added to the database. Keeping the data scripts separate provides one important advantage over using installation scripts that include data. The data files will be processed in another step, after all installation scripts are applied. Line 344 runs the process of applying all data install and data upgrade scripts. Good. We created our setup script for the module. To remove that exception, the script still needs one detail to be added to the config.xml file. Once we have done this, we will run it again and check whether our table has been successfully created. Our next step: define the model and resource. At last, we come to our hero of the day, the model. In Magento, we use models to work with data, and resource models to access the storage layer. We'll explain more about the model versus resource model approach in a later video. This dichotomy is uncommon. For now, we'll add the necessary configuration for the model and resource model, then we'll create the class files. Open your config.xml file and add the code you see on lines 18 through 32. These lines define the model checkout comments and its resource model checkout comments_resource. For the checkout comments_resource, we define the entities entry. That code allows the system to find the table name for our setup script. Finally, we should have resolved the exception, and we can create the table with the setup script we wrote before. If you refresh any Magento page now, that exception disappears. Excellent! In my case, I specified C3 as the table name prefix during the Magento installation, and you see that the table C3 checkout comments was successfully created. Moreover, in core_resource, we now see our module information. Now the system knows that the resource, named checkout comments_setup version 001, was installed, and it won't look for setup script files unless we change our version number. Okay, defining the model and the resource model allowed us to finish the previous step and got us ready to use the table in a database. Now let's continue our model-related work and create our model. In this video, we are going to create a model and resource model classes. Open your modules folder and create a folder named Model. It must be named with initial caps. Then, create the file comment.php in initial caps as well, inside that folder. Our next step is to add some code in the file. Open that file and add the code you see on the screen. If you followed the method _init in the model, you will find out that it sets the name of the resource's model. We specify the string checkout comments/comment for this purpose. So the model will try to initialize its resource model when instantiated. Next, we need to create a resource model. Create the resource folder inside the model folder. Again, use initial caps. Then, create the file comment.php with initial caps as well. Open the file and add this code, shown on the screen. Notice that we used comment in singular to name these files. That is correct, since technically each instance of a model corresponds to a single comment. In our case, it will correspond to one row in a database table. Keep that in mind when naming the model and its resource model files and classes. So basically, a model is made up of a folder named model and a file named entity.php. A resource model is made up of a folder nested in the model folder named resource and a file named entity.php. These two folder names, model and resource, are not hard-coded, but we strongly recommend you stick to this naming convention. You may notice that the model and the resource model have a very similar construct methods. First, both start from one underscore construct. This is an important detail to remember. Second, both run the underscore init function, but in the case of the resource model, the parameters differ. Here we pass the table name and the primary field as parameters. That is all we have to do to get the ability to store values in a database. No insert or update SQL operators are needed. This logic is hidden under the hood. Okay, our next step is to use this model to save customer comments. On to the next video. The next step is to create our custom layout update file, and we start by defining it. Let's open our config.xml file and add the code shown on lines 35 through 43. In this course, we don't want to create a new theme for the module. Since we are familiar with the design fallback mechanism, we know that the system will try the default theme of the base package when a file is not found in the specified theme. And we cannot know which theme and package is set on the targeted Magento installation. Given this, we are going to place our layout update file in the default theme of the base package. Open Design Front-End Base Default Layout and create a folder named Practice. This is how we separate out the file from the rest of the core layout update files. Then, create a file named checkoutcomments.xml in that folder. Remember how we defined the file in our config.xml? Practice/checkoutcomments.xml? Good. Open that file and add the code you see on the screen. You now understand what the code does. It replaces the template file for the Checkout one-page agreements block with another file. But we deleted the review block in our previous course for one-page checkout in order to create one-step checkout. As a result, the system will not use this handle, Checkout one-page review. If you have that module, one-step checkout, in your system, you need to deactivate it in its initial configuration file by setting the active flag to false. Okay, on to the next step, creating the template file we just defined in the action of the handle. Open Design Front-End Base Default Template and create a new folder named Practice. Then, create a folder named Checkout Comments inside the Practice folder. The next folder in the template path we specified in our layout update file was one page. Let's create it. Now we need to copy into that folder the original file from Design Front-End Base Default Template Checkout one-page agreements.html. And rename it to comments-agreements.html. Great! Now the system will use this file instead of the original. Our next step is to add a text area in a form in the Magento Checkout Review step. So, add the code you see on lines 33 through 45 between the comments Start of Checkout Comments code and End of Checkout Comments code. Then, comment out lines 47 through 49 of the original file. Scroll to the end of the file and add one more line as you see here on line 65. Again, it's between the comments Start of Checkout Comments code and End of Checkout Comments code. We manipulated the original code in this way to get our text area located inside the form tag, regardless of whether agreements are turned on or not. Now, our text area and list of additional agreements will work together. When you open your checkout page, you will see this text area we just created. If not, make sure to turn off your cache. This allows you to see all your changes while developing code. Excellent! We created a template for the front end. Now your customer can write a comment, and this comment will be sent as a value of the Checkout Comments field in a post array. Now we need to catch this value and store it in our table. Let's do this in the next video. So, we want to allow customers to include comments or special instructions with an order. To do that, we need to insert our customer functionality in a specific place in the order flow where we know for sure that the order was successfully created. How do we do that? It's time to introduce one new concept we need to use: event observers. Based on your previous knowledge, you might choose to create a controller to receive customer comments. The controller might include rewriting routes and overriding methods. In this course, we'll add another tool for your development toolbox, the Event Observer mechanism. You may find this approach more efficient. In a nutshell, at strategic points in the system code, Magento checks whether an observer is registered. We refer to these places in the code as events. The Event Observer mechanism allows us to watch for events and invoke our code when the event occurs. In Magento, the observer concept is very close to the listener concept, which is popular in other programming languages. For example, when the system stores an order, it fires lots of events, and among them is the sales order placed after event. Our model relies on this event. Before we define an event observer, let's see where the system fires that event. Open the Mage Sales Model Order.php file and scroll to line 1074. This code allows us to inject our custom logic in the middle of line 1074 and 1075. Yes, it can seem opaque, but don't be dismayed. The system has a mechanism to register as many observers as you want for every event we have in Magento. If we run a search through the code folder with Mage Dispatch Event as a query, we'll find 354 calls of that method. You see how this concept is popular in code, and how many places we have in the code where we can inject our own logic. In general, to use the Event Observer mechanism, we first define an observer, then we create it. To define or register an event observer, open your config.xml file and add the code you see on lines 44 through 62. Notice that we are creating this in the front-end area. We want to target our observer to events in the front-end area. Here, we registered two observers. The first one is Controller Action Pre-Dispatch Checkout One-Page Save Order, shown on line 45. The second one is Sales Order Place After, shown on line 54. These nodes from lines 45 and 54 contain event names. We want that when the Controller Action Pre-Dispatch Checkout One-Page Save Order event is fired, the system uses our Save Checkout Comments observer. We define that observer on line 47. To perform this, the system instantiates the class specified on line 48 and run the method specified on line 49. That will happen only when the system fires the Controller Action Pre-Dispatch Checkout One-Page Save Order event. The name of the event is dynamic. To find where it is located, run a search using a part of the event name, Controller Action Pre-Dispatch. The place in the code we were looking for is located in Mage Core Controller Variant Action class on lines 511 through 514. Do you remember what the getFullActionName method returns when you save an order? Correct. It's a string named Checkout One-Page Save Order. Given that every action controller extends Mage Core Controller Variant Action and runs the pre-dispatch method, we can easily penetrate into any controller logic and set or get the data we need. You see that our observer will run only when a customer places a new order, because in other cases, getFullActionName will return other values. Good. That's how you register an event observer. Our next step is to create an observer class. Let's learn how to create the observer. We treat observers in the same way we do models. They are located in the model folder in a single file called observer.php for each module. And to instantiate them, the MageGetModel or MageGetSingleton methods are used. So open your model folder and create the file observer.php with initial caps. Open that file and add the code you see here. What does this single method do? It may help if you remember when the system runs it. We define that method prepareCheckoutComment in our config.xml file on line 49, and we expected that when the system fires the controller action predispatch checkout one-page save order event, it also calls the prepareCheckoutComment method. All data that is available inside the predispatch method of a controller that the system called for that action, all that data is wrapped inside the observer object we have as a parameter on line 5. That allowed us to get the value of the checkout comments field of a post on line 9, and then set it in a session object using the magic setter setCheckoutComment method. We use the word prepare to prefix the method name because the goal of the method is to prepare the data and stash it until we know that the system saved the order successfully, and then we can save the data in our custom table. One small detail about magic setters. This approach may be confusing for those who are new to studying Magento code. You see the setCheckoutComment method and want to locate its declaration, but alas, you found nothing. And how is this supposed to work, you may ask? Many Magento classes extend the variant_object class in their depth. That class overrides the PHP magic method __ call. PHP runs this method when a requested method does not exist. The code you see on the screen allows you to easily create dynamic setter and getter methods. For purposes of our custom module, the only thing you need to care about is whether this method name actually exists. If the method name does not exist, magic getters or setters take center stage. Okay, go back to our config.xml. The next method the system will call is saveCheckoutComment. It will run the method on the sales order place after event. That is a place where we can be sure that the order was successfully created and we can start saving our comment. Open our observer again and add the code you see on lines 13 through 26. The variable order, line 15, now contains the information we need, for example, the order ID, because the order has already been placed into the database. And the message variable, on line 16, contains the comment that we received via the magic getter, getCheckoutComment. Then, on line 22, we created an instance of our model using the static method getModel. Then we set the order ID and comment via the magic setters and call the save method. That is how we usually work with a model. If you try to place your order now and specify your comment, you will see a new record in the database. Excellent! We've created our observer, so we can now save customer comments into the database. Our next step is to display stored values to a customer and to an administrator. We do this in the next videos. In this video, we add the functionality to show comments for a customer in his or her profile. To get this functionality, we need a number of items, all for the front end: a menu item in the profile via the Layout Update file, a controller, a new handle in our Layout Update file, a block, and a template. Open your Layout Update file and add the code you see on the screen, lines 11 through 19. How does it work? If you log into Magento as a customer and visit the customer profile, you will find a new item in the left menu, Checkout Comments. Notice the way we added a new item to the customer's menu simply by using the layout action Add Link. The title of the link was rendered based on the label parameter, and the URL was rendered based on the path parameter passed to the Add Link method. Given that we haven't defined a controller for the Checkout Comments route, you will see a 404 page if you click on the link. Let's define and create the controller now. Open your config.xml file and add the code from line 70 through 78. Then, create a controllers folder and add a listcontrollers.php file in there. Open the file and add the code you see on this screen. This simple controller has only one method, index action. The functionality of the method relies on the layout mechanism. Remember, we said earlier that some controllers' method consists only of load layout and render layout method invocations, and here we have just that situation. Let's define the required instructions in our front-end layout update file. Open the checkoutcomments.xml file again and add the last piece of information in that file. See lines 21 through 27 on the screen. What does this layout handle do? Notice line 22. Here, we use an update directive to extend this handle from another, the customer account handle. Then, we add a new block to the content block with the name checkoutcomments.list. See line 24. This block uses a new template. See line 25. Excellent. Let's create the block in template. To let a module use its own blocks, we need to define a class prefix for a block group. Open our config.xml and add the code you see on lines 34 through 38 on the screen. These lines must be in the global node. Then, create the block folder in your module directory and add a list.php file in there. In our layout update file, we specify the type for the block as checkoutcomments/list. Based on what we have specified in the config.xml file, this type now points to the class practice_checkoutcomments_block_list. So let's create this class. We'll need one method in the class. Let's call it getComments. Verify that your class declaration is correct, and add the code for the body of the getComments method to match what you see here on the screen. You can easily guess the meaning of some of the lines in this small piece of code. The getData and setData methods let you cache the results of the contain between them routine to increase performance. This is a pattern you will find often in Magento, where it uses getter and setter methods. The most important code for you is on line 10, where we create an instance of a resource collection. This is when we meet a new concept, a collection. We're writing this in advance, since the collection does not exist yet. We'll create the collection later. We use the Mage getResource_singleton_factory method to instantiate the resource collection model. We will be speaking more about instantiation resource models in a later video. On line 11, we call one method of the collection, addCustomerFilter, using current customer data from the session. We do this to hide comments from other customers. What does the getComments method return? The comments variable, which is a collection of the comment model instances. Of course, we don't have the collection class yet, but before we create that, let's finish the last step we need for the block. Let's create the template. Open your template folder, Design Front-End Base Default Template Practice, and add the template file we specified in the layout update, which is practice/checkout-comments/list.phtml. We have the checkout comments folder already, so create the list.phtml file in there. Open the file and add the code you see on the screen. The lines of interest are 8 through 19. Here, we call the getComments method of the block and use the comment ID, the comment value, the product name, the order status, and the creation date to build a table of comments. Also, we create a link to an order based on the order ID on lines 14 through 17. Notice that we are using those magic getters again, which means that we won't find all the methods in the block or in the model objects. This is Magento's way of getting values of a model, or, going more deeply, of getting values of table fields that stand behind the model. Excellent! We prepared the files and code we need to display the collection of comments. Our next step is to create a collection class. We need to create a file and then add 2 new methods. Let's move on. In the previous video, we started to use a collection which does not exist yet. On line 10 of our block, we create a collection instance. The getResourceSingleton method will try to instantiate the Practice Checkout Comments Model Resource Comment Collection class. That name helps us to understand where we should create a file and folder for the collection. First, we need to create a comment folder in a resource folder, then collection.php file inside. Let's do this. Create the comment folder, then create a file, collection.php. Remember the initial caps. Open the file and declare the collection class extending from the class MageCore Model Resource DB Collection Abstract. Most of the time, we extend this abstract class while creating collections. Make sure that the rest of the code looks like you see here. The only method you see on the screen is one_construct. Look carefully. It has only one preceding underscore, just like the construct method we had in the model and resource model, remember? The method calls the _init method, and as a parameter, it receives the model class ID. So what was the collection concept designed for? The purpose of a collection class is to serve as a container for a set of models. In other words, a set or collection of objects of a given model. That is what collections are for. Now our collection is almost ready, and if we hadn't used the additional method, addCustomerFilter, we would be done right now. Okay, let's take a shortcut. If you comment out line 11 in the block class to prevent the exception, you will see a page as follows. In my case, I see the ID and the text of the comment. These values were taken from our table, Checkout Comments. The collection has gathered all available data and created an instance of the model for each row. But we don't have the product name, order ID, and status, which we were expecting when we wrote the template. Look at line 12 or 13. By the way, we don't even have the created_at value. Calling getCreatedAt on a comment object on line 16 returns null, just as it does for the rest of the currently unavailable fields. But because we pass its value through the formatDate method, it deceives us by returning the current timestamp in the case of the value null. We took this shortcut to show you the result with the least amount of code within the collection, model, and resource model, so you can see that it actually works. The actual SQL queries are deeply hidden and abstracted. Okay, we created our first collection, and it's usable even though it doesn't yet return all of the information we would like to get from it. Now we need to create one more method to provide the missing information and to filter records by the current customer. Let's do this next. Open your collection.php file and add the function Add Customer Filter. You can see it on the screen on lines 11 through 31. In the method, we can retrieve the current select object via the getSelect method and modify it. The select object is an instance of variant dbSelect, which extends Zen dbSelect. You can see this call on line 13. Then, on line 14 through 19, we add a filter to hide comments not associated with the current customer ID if a customer is logged in. Just to be on the safe side, we apply a restriction that hides all comments on line 18 if no customer is logged in. Take a look at lines 20 and 23. These two joins allow us to show the status and created at fields out of the join tables. Since there can be more than one product associated with an order, we use the method group on line 29, and we concatenate all product names using the group concat function of a database. Because this function isn't part of the SQL standard, we don't use it directly in code. Instead, we call the method addGroupConcatColumn of the core resource helper. This is a safe approach when writing cross-database code. By the way, we touched on one new concept here, the resource helper. This is where you can put all resource model-related code which can be useful in other parts of the system. To instantiate a resource helper, we use the static method getResourceHelper, as you can see on line 28. The system instantiates the appropriate helper based on the helper name and the database engine being used. Study the way we use the select object. The methods where and join will modify the query based on the parameters we provide. Instead of hard-coding these conditions as plain text, we use universal or cross-database code here. Then, a database-related adapter will compose a correct query string by processing all the data of the select object. Another benefit of this approach is that we can access this select object from anywhere in the code and edit it to adjust the results to our needs. Now we have the Add Customer Filter method, so we can safely uncomment line 11 in our block class. Let's check how it works. Now the table contains all the information we expected. The product name, the status, and the time of creation are all added to the table row. Also, we can feel confident that a customer won't see the comments of another customer. Let's go to the next step, creating the functionality to display a comment to the administrator. Now, let's take a different approach. Let's use a model and resource model without a collection. We'll use this technique to show customer comments to an administrator. Open your config.xml and add the code you see here on lines 81 through 92. This code defines a new event observer. The observer's name is displayCheckoutComment, as shown on line 85. It's listening to core block abstract2html after event on line 83. And when that event fires, the system will create an instance of the Checkout Comments observer class on line 86 and call its displayCheckoutComment method on line 87. You might have noticed that all this will happen only within the admin area, because we declared the observer in the admin HTML node on line 81. Excellent! The class we want to use here already exists. We will use the same observer class we used before. The next step is to create the new method. Open your observer.php file and add the code you see on lines 28 through 47. Since we registered a new event observer for the core block abstract2 HTML after event, the display checkout comment method will be called fairly often. In fact, the system will dispatch that event for every block it needs to build a page. If you run a search against core code with the event name as a query, you will find the place where the system fires the event. It is in the toHTML method of the Mage Core Block Abstract class. It is on lines 886 and 887. Remember that all blocks in Magento extend from that class, which means the system will call our observer method when it calls the toHTML method for each block used. By using the event observer on that event, we want to hook into the process at a point when a block has already been rendered, but the output has not been returned yet. To determine that we are on the correct page and in the correct place, we use the getNameAndLayout method of each block and for each block's parent block. Then we compare if the return name is equal to gift option string for the block and is equal to order tab info string for the parent block on lines 33 and 34. In this case, we can be sure that we are in the correct page, at the correct place, which is the order view in the administration panel. Let's open it. Navigate to Sales Orders, and then click on the grid row of an order where you specified a checkout comment. Do you see the checkout comment block on the page? No, I don't. Let's find out why. Go back to our Observer method. We get an instance of the comment model on line 37. Then we call its load method with an order ID value and the corresponding field name as parameters. Then we check if the system was able to load this comment by calling its getID method on line 38. Then we call the getTransport and getHTML methods to retrieve the HTML content of the current block that triggered the event. See line 39. This may seem opaque because here the magic setters and the observer mechanism are mixed. Let me clarify how it works. Open the Mage Core Block Abstract class again, and take a look at the method toHTML where the event is dispatched. The second argument to the dispatch event method defines the parameters passed to the event observer method. The transport array key contains the transport object variable. This variable contains an instance of the variant object class, allowing us to use magic getters and setters. So this is what we do on line 885 to set the HTML output of the block. Then, the system passes the array by the dispatch event method call into the observer object on lines 1272 or 1278. And since the observer object passed to our method extends the variant object as well, we were able to use magic getters on it as we do on line 39. Here, we retrieve the value of the transport key from that array. Our goal here is to append another block's output. We do this concatenation on line 43. We join the HTML string of that block with the HTML string of our new block, and then we set this new string back on the transport object using the magic setter method setHTML. This is how we can insert a new block in the middle of existing blocks using the event observer mechanism. Now that we understand the mechanism of appending new HTML to a block, take a look at the code in the middle of our method on lines 40 through 42. This code is an example where we create a block directly in PHP without a layout XML directive. We create an instance of the admin HTML/template block on line 40. This is a core class, the Mage admin HTML block template class. This class fits our purposes. Then we set our custom template and the comment model object via magic setters on the block. By the way, blocks also extend the variant object class, which is why we can use magic setters here. So given all this information, why didn't our block show up on the order page? Oh, we don't have this template yet. Now we need to create this file. Open the Design Admin HTML Default Template folder and create a new folder named Practice, then a folder named Checkout Comment, and then create a file named comment.phtml. These file and folder names are all lowercase. Add the code you see on the screen. This code is mostly an HTML representation of a block to make it look like the rest of the content on the order page. The only line of interest is line 10. Here, we have the magic getter getComment to get the value of the comment field of our model, which is the model we are receiving via the magic getter getCommentModel. We escape this comment string using the method escapeHTML to prevent XSS attacks. The call of getCommentModel is the counterpart to the setCommentModel called on line 42 of our observer method. First, we set the value on the block. Then, we get the value in our template. Great, we've finished coding. Let's check if it works. Congratulations! Now we have comment text within the order information in the case where a customer decided to add a comment. The module we wrote is capable of saving and reading values to and from the database. We integrated additional functionality into core pages to allow a customer to enter an arbitrary comment for an order and display it on the customer profile. Moreover, we also injected the additional block into the order view page for the administrator. The observer mechanism was very helpful in achieving this functionality. But you may feel that the concepts of model, resource model, and collection are still a black box for you. Let's discuss these concepts in the next video. In this video, I'd like to delve into the model and resource model concepts. If you recall, our custom module contains 3 scenarios: to save a record, to read a record, and to load a collection of records. In this video, we concentrate on the first 2 scenarios. Saving and reading a record we can rephrase as saving and loading a model. In fact, that is the main role of a model. To store the model, the system usually uses one row in a database table. In the administration panel, we added a custom block with a comment for an order. This functionality is located in our display checkout comment method. So how does that code work? On line 37, the system creates the model instance of the checkout comments/comment class and then loads the model. We provided an ID value and a field name as parameters. Here, the system runs the select from our table command with data provided and assigns retrieved data to the model. To put it simply, the model now contains values of a specified row of a table, and as you see on line 38, we check if a matching record was found in the database table. Take a look at line 22. Here, we create an instance of the model, and then set 2 values, an order ID and a string with a comment. Then we call the save method. When we call the save method, the system inserts or updates the corresponding row of the table. The use of a model abstracts our work with the database. We don't think about the database or tables. We work with an object which can read, save, and delete itself. As you might notice, in this scenario we didn't use a collection because we needed only one record. To get the record from a database, the model uses the resource model. If we organize these two ideas in a sequence as they retrieve a value from a database, they will be ordered as you see on the screen. A model uses a resource model, then the resource model uses Varian and Zend libraries. As a matter of fact, the model and resource model represent one functional unit, but with different roles. A model is where you put all business-related logic. A resource model is where all storage-related functionality is located. It mostly deals with the SQL queries. Why do we separate them? When we load a collection of models to show as a table, we won't instantiate resource models for each model because we are not going to save them. We will use only the model's objects. You'll recognize this as the principle of single responsibility in OOP. Okay, let's go through the instantiating model scenario as the PHP interpreter does. Keep in mind that to instantiate a model, we don't use direct instantiating. It is deprecated, or I would even say forbidden, in Magento. Instead, we use the static method getModel for this purpose. If you need a single instance of a model, use the getSingleton method instead. What is happening when we instantiate a model on lines 22 or 37? First, the system composes a class name for the model on line 1347 of the Magento Model Config class, and then, on line 1350, it creates an object of the model. A short side trip. How does the system compose that class name? It uses the getModelClassName method, which in turn uses the data of our config.xml class. Since we have passed the checkoutComments comment string as a parameter to the method calls the getGroukedClassName method with a model word as the first parameter and our string as the second parameter. This method, getGroukedClassName, is a unified method and is used to compose names not only for models, but for any entries in the global node. The model word works there as a sort of determiner. You can see that on line 1229. In our case, on that line, the system retrieves the content of the models-checkoutComments node of our config.xml, which are lines 20 and 21. Then, it takes the practice.checkoutComments model value and appends the comment word with an underscore as a sort of glue. And the result is the class name, practice.checkoutComments model comment. Excellent! You just saw the transformation process of the checkoutComments/comment string into practice_checkoutComments_model_comment. Remember this. To create that path, use the model identifier on line 19 and then slash and then the last part of a name of a particular class. To put it plainly, we can say that checkoutComments serves as an alias for the model class name prefix, or as a name of a group of models. Our practice.checkoutComments model comment class extends the Magento model abstract class, which is a general rule for models in Magento. But we don't have the native constructor in both classes. The abstract class extends Varian object in its turn. This is where you find out what is happening on a model instantiation step. Here is the reason why we don't have the native PHP__construct method in those classes. We want to allow some logic of Varian object to be executed before creating a model. In the end of the method, on line 112, we have a call of the one_construct method. That is the method we need to use as a constructor in models, and that is the only method of our model. Here is when it will be called. What's next? The system runs the _init method of a model to set the name of the resource model. Where does this method take us? Take a look at lines 108 and then 121. At this stage, the system has an instance of a model which knows only the name of its resource. Here is the culmination. The init method of the model does not create an instance of a resource model, it only sets a name. So when is the resource model instantiated? Come back to our observer.php and look at the next step. It's the save method on line 25. The save method of a model is when the resource model is instantiated. The method's body is quite long, but I recommend that you study its detail on your own. Here, we follow only one line, line 318. The getResource method is where the system starts using the resource model to save values. First, it instantiates a resource model, and then it calls the save method of the resource model instance. So you see how the resource model appends the model's functionality on the storing step, and at the same time, these two remain separate objects. Which class name will the system use for the resource model? As you remember, all the model object knows about the resource model is the identifier checkoutComments/comment. And the system calls the static method getResourceSingleton with the value. See line 139. Tracing this thread, we come to the getResourceSingleton and getResourceModel methods of the Mage class. After that, go through the getResourceModel instance, getResourceModel factory class name, and getModel instance methods of the Mage core model config class. When the system calls getResourceModel factory class name with our string as a parameter, it retrieves a real resource name. The checkoutComments/comment string we set, in fact, wasn't a resource class identifier or path. Actually, the string is a model class, as you can see on line 1599. That is the string's real meaning, based on the name of the parameter. This method, with such an easy-to-remember name, getResourceModel factory class name, finds the resource name that is defined for the model class. Lines 1611 and 1613 help us understand that the system takes the value on line 21 of the resource model node and then concatenates it with the second part of our string, the comment word, using the slash. Voila! The result is checkoutComments_resource/comment. That is the resource name, which the system treats as a regular model, creating an instance of the resource model via the getModelInstance method. The system uses the getModelInstance method for models, resource models, observers, and so on. That is why we have the model definition, lines 19 through 22, and the resource model definition, lines 24 through 31, on the same level. The value of line 21 serves as a link to line 24 and connects the model to its resource model. As for the class name of the resource model, based on the logic of the getGroukedClassName method, if you look at line 25 now, you will easily realize that for the string checkoutComments/comment, the name will be Practice Checkout Comments Model Resource Comment. Okay, let's go back to our abstract class of a model. See line 318. Now you know what's going on after the getResource method call. The model creates its resource model when needed. Here are the ways you can retrieve an object of a resource model, following Magento's recommended practice, which is to avoid hard-coding class names. Next, the system calls the save method of a resource model. The body of the save method is in the Mage core model resource DB abstract class. We extend our resource model from that class. In prior releases of Magento, you may find that resource model classes extend Mage core model MySQL 4 abstract. As of version 1600, We use Magento Model Resource DB Abstract for resource models instead. Since we're talking about changes, in earlier versions of Magento, before version 1600, we used MySQL 4 as a name for the folder with the resource models. Now we name it Resource. We recommend you follow the new approach if you're working with Magento version 1600 and later. Take a look at the Poll module. It has the MySQL 4 folder and the same nesting of files as in the resource folder. But these files are empty and simply extend the real classes from the resource folder. To provide backward compatibility, you can apply this approach when writing modules. Remember then, extending the Magento Model MySQL 4 abstract for resource models is now deprecated. Let's proceed. This is a model of an inheritance for our resource model, Practice Checkout Comments Resource Comment. The new class, Magento Model Resource DB Abstract, extends Magento Model Resource Abstract. That is where you find the native PHP constructor. Here again, we are advised not to use the native PHP constructor, but to use the _construct instead on line 44, as we did for the model. Excellent. That brings us to our single method in the resource model, _construct. When the system instantiates the resource model, it calls our _construct and the _init method. This method is intended to set a table name and a primary field name for the resource model object. One single line has hidden detail that may confuse you. How should you define a table name here in the _init method? The table name is defined in our config.xml file inside a table node, which is inside the entities node of the resource model definition. What have we written in our init method? Do you remember? Checkout comments /comment _table. Let's learn how it works so that we know how to define a table name in our init method. The init method of the abstract class calls the _setMainTable method. Take a look at the _setMainTable method. It splits our string at the slash and uses the first part as a resource name and the second part as a table name. Analyzing these two methods, _setMainTable and setResource, we see that our string checkout comments /comments _table is split into two parts by the slash. The checkout comments part is sent to the resource model variable on line 184. The main table variable keeps the second part of the string comments table. See line 211. When on line 318 the system runs the save method, it runs code that you can see on line 448. We won't go into detailed explanation of all 50 lines of the method's body. The general idea of the method is to decide whether it should update or insert. You can study it on your own. Let's examine only one line of the code. In our case, the system will insert a new value, and this line is line 448. The bind variable will contain an array of values we've set in our observer on lines 23 and 24. To compose a SQL query inserting these values, the system needs to know a real table name. So it calls getMainTable, which in turn calls the getTable method, which in turn calls getTableName of the Magento Model Resource class on line 284 in our case. The model entity variable contains the same value as in the beginning, checkout comments /comments _table. The system concatenates this string again on line 278. It uses the value of the _resource model variable, which stands for checkout comments. This is a bit tricky because, in fact, it stores a name of a model. Then the system calls the method getTableName with a parameter. Here on line 265, the system uses a model name to get a resource model name, and only then, on line 270, it retrieves a name of a table from the table node. That helps us understand the way to define and then refer to a table. To define a table, use the predefined entities node on line 26, then the nested entity name node on line 27, and then the table node on line 28. To retrieve that value, check out _comments on line 28. You need the model identifier on line 19, then slash, then entity name node on line 27. As we did in our resource model on line 8. Now we can take a second look at line 448. How does this insert method work? You may wonder what object the getWriteAdapter method returns. In our case, it returns an object of the VariantDBAdapter PDO MySQL class, and that is usually the case when we work with MySQL. That is when we come to the third block on this slide, the variant layer. We use the VariantDBAdapter PDO MySQL class from the lib folder, which extends the Zend adapter and adds some useful functionality. If you open the VariantDBAdapter, you won't find the method insert because the adapter doesn't override the method. Even the parent, ZendDBAdapter PDO MySQL, doesn't do this. The method is located in the ZendDBAdapter abstract class. Bingo! Here we finally found those painfully familiar lines of the SQL query. They appear to be at the very bottom of our long search, lines 565 through 568 of ZendDBAdapter abstract. Good. Look at the slide. Starting from the observer where we instantiated our model, we came across several classes. Our model extends the MageCore Model abstract class, where the method save is located. When we call the method save of a model, the model called the method save of the resource model, which in turn called the insert method of the database adapter, which in our case is VariantDBAdapter PDO MySQL. A database adapter in Magento is quite a complex thing. Take a look at the slide. The adapter object that we use in the resource model, calling the insert method, actually extends 3 more classes. That is quite a lot of code. These classes do some work on our data before storing data in a database. By default, the database adapter in Magento uses the PDO_MySQL extension of PHP. So where is a place where the system will use that native PHP object, or in other words, where is a border with the native PHP? We stopped here on line 574. But a real call of a PDO object will happen on line 228 or 230 of the ZendDB statement PDO class. Here, the _stmt variable stands for a native PHP object, and Magento's code borders the PHP extension. If you want to debug SQL queries, use the query method of the ZendDBAdapter PDO abstract class. You can check the content of the SQL variable or output it somehow to see what is going on. But maybe you'll find it more useful to turn on logging functionality with the help of the variables of the VariantDBAdapter PDO MySQL class. Set the _debug variable on line 98 to true, and then check the var/debug folder. You'll find the PDO_MySQL.log file with all queries longer than 5/100ths of a minute. That interval is a value of the next variable, log query time, on line 105. By the way, you can turn this limit off using the log all queries variable by just setting it to true. See line 112. Here is my log file. It contains pretty useful information and can be very useful when troubleshooting your code. We mentioned that in our module we use 3 different scenarios, and now we've finished tracing the first one, how the model stores values in a database. How the model will load a value is very similar, and we won't cover this now. So when a client asks you to implement a module that loads a single record from a database table, for example, this tool, Model plus Resource Model, is a good one to consider. Let's cover the third scenario in the next video. When we need to show a grid, list, or table with many values, we use a collection. Let's delve into collections. In this case, our scenario works as follows. Our collection will load all requested values from a database and create a model for each record. Since on this step we only load values to show, not to save, we don't instantiate resource models of the models. That is how our collection works for a customer profile, where we show all the customer's comments for orders. We don't use the save functionality of a collection, but you can take a look at the slide and analyze the difference. Here you see that the collection object runs for each for its dataset and calls the save method of each item, which is a model object. The rest is exactly the same logic that we have already learned in previous videos for a model and resource model. Now let's open our collection. Looks pretty familiar, right? The same one_construct and one_init methods. Note, first of all, the inheritance model. Our collection extends Magento Model Resource DB Collection Abstract, which is the general case. The inheritance model of a collection in Magento is as follows. As you see, a collection extends 2 classes of the Variant library. The Variant Data Collection class implements 2 interfaces, Iterator Aggregate and Countable. What does this mean for us? It's a very important thing to know. The system handles the collection in 2 stages. First, the system instantiates the collection object. And second, it loads and traverses the collection's values to build a list or table. Line 10 of our block is a place for the first stage, the initiation. The comments variable contains the collection object. But what do we have in this object after the getComments method returns the object? In fact, not much. If you've never implemented the Iterator Aggregate interface, you may find it difficult to understand what happens when the system traverses collections. First off, how can you instantiate a collection? To instantiate a collection, you can use these 3 approaches shown on the screen. But again, don't use direct instantiation. In our block, we use the second one shown here. The native PHP constructor is located in Magento Model Resource DB Collection Abstract. If you analyze this method, you'll find that the only data the collection keeps is the connection object on line 134 and the simple select object on line 135. On line 132, it runs the one_construct method, which in its turn runs the _init method of our collection. What does the string checkoutComments/comment mean here? That string is a name of a model. The collection stores its name in a setModel method. The only thing that takes place here is that the system gets the real model class name and keeps it in the item object class variable for future use. No instantiation takes place. The method addCustomFilter runs immediately after that in our block. And this method modifies that simple select object that we mentioned. But when will the system load data from a database? When will this select be executed? Open your template file list.phtml. Take a look at line 6 and then line 8. In both cases, we call the same method, and due to the caching logic we have in the method, the second call is very efficient. The method does not do the same thing over and over because of lines 7, 8, and 12. Well, the logic of the getSize method is located in the Variant Data Collection DB class, and it is quite obvious. Let's look at how the collection's getSize method works. We want to check whether our select produces a result or not, so this getSize method effectively allows us to check the count of an as yet empty collection. By the way, you can apply a regular PHP count function to the collection object because the collection implements the countable interface. And as you see on line 738, the collection provides its functionality overriding the count function. Firstly, the system loads the collection, line 740. Then, on the next line, it counts the items of the collection. But what about the second call, on line 8? That is how we usually work with collections in Magento. Since the collection implements the iterator aggregate interface and provides corresponding functionality, we can simply put it inside that for each. On the for each step, the system will call the getIterator method of the Variant Data Collection class. Take a look at lines 728 through 732. That is when the system will preload data from the database. The load method is defined in the Variant Data Collection class, but then it is overridden by the Variant Data Collection DB class. Look at the method's body. The method getData runs the fetchAll method of the adapter and returns all requested rows in the data variable on line 521. Then look at the main logic of loading the collection process. The for each cycle starts from line 525. The item variable is an instance of a model because the getNewEmptyItem method creates an instance of the previously set class name. Remember, we pass the name via the _init method of our custom collection. The next lines, 530 and 531, are pretty obvious. The system inserts each next row of data retrieved from a database into the model object, and then adds the object to the collection. So now you can see what happens when the system runs the for each command on line 8. When the system calls the getIterator method, it wraps all the available items of the collection into an arrayIterator class on line 731, and then returns the instance to the for each command. Then, the for each command iterates each item. The item is, in essence, an instance of a model. And you see the results as the table of comments. Great! Now you're quite familiar with the role and functionality of a collection in Magento. So when a client asks you to implement a module that loads a list of values from a database, for example, this tool, Collection, is a good one to consider. Congratulations! Now we've reached the final point of our long story. In this third course, you learned how to use a model, the M letter of MVC. You got a detailed understanding of the model, resource model, and collection concepts. You created a working model capable of storing customer comments in a database. Then, you extended the model's functionality by adding a collection. That allowed a customer to find all his comments in the customer profile. And then you extended the model's functionality again to show this information to the Magento administrator using just a model and resource model. We traced how the model uses the resource model and learned the ways that Magento interacts with a database. Then you saw the mechanism of loading the collection and studied how collections in Magento extend the native PHP functionality of the iterator aggregate interface. Along the way, we took a close look at how to work with setup scripts. You learned the purpose of the SQL folder of a model. We mentioned that for importing data into a database, we prefer using another folder, which is the folder on the same level as the SQL folder. The event observer mechanism is a very important component of our model. and in this course, you also learn the basics of how to work with the observer. Given all the material you learned in all 3 courses, you are now ready to meet many of the challenges in writing your customizations. Thank you for watching. Be sure and visit the Magento support site for more learning resources.